infinite series. Now we're going to solve for the sum. We're going to add a series all the way up to infinity. Only a geometric series. So remember, let's review what we did yesterday. Remember yesterday, when I say yesterday, what do I mean by yesterday, Miley? Last week, last Friday, we had the sum of the series. Remember, so you don't need to write this down. You don't need to write this down. What I'm going to do is Godzilla versus Kong time, right? You don't have to write this down. You can just write, you can if you want, but this is just for review. Remember, we had a geometric series. Is a to the n is the first term times the common ratio raised to the n minus 1 power, right? We talked about that. And then we can find, this was the sequence, but we can find the series is when we add them up, okay? When we add them up. So let's say we have a solution. Let's say we have a geometric sequence where the first term is 3, the common ratio is 2, and we have the n minus 1, okay? Now, what does that mean? Again, you don't have to write this down. This is just for review. We can say this, right? We have here the term, the rule, and we go here, what is the first term? What is the second term? What is the third term? What is the fourth term? What is the fifth term, right? And we say, the first term we plug in 1, right? 3 to the 2 to the 1 minus 1 is 3 times 2 to the 0, which is 3. Then we have 3 to the 2 to the 2 minus 1, which is 3 times 2, which is 6. And then 3 to the 2 to the 3 minus 1, which is 3 times 4, which is 12. And you can see these are all doubling. This will be 24. This will be 48. My phone's blowing up. I want to make sure it's not an emergency. Why is my phone blowing up? Okay. So, all right. Now, so we understand how we got the terms. The first term is 3, 6. And you can see that because my common ratio is 2, it means I multiply these by 2. 3 times 2 is 6. 6 times 2 is 12. Blah, 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 blah. My first term is 3, and that's my first term, right? Remember, first term, common ratio. You got to remember that. This is the first term. This is the common ratio. Okay? Now, to continue what we did last week, I said, hey, let's figure out what the series is by adding them up. The first term all the way up to the, let's say, the fourth term, right? This says add them. This tells you to add them up, the first term to the fourth term, 4. So what would the answer of this be? This means add 3 plus 6 plus 12 plus 24. We can add them up, right? So we're going from the first term to the fourth term, we add them up, and we get, let's see, 9 plus 12 is 21, plus 24 is 45. I think, is that right? 45? This plus this plus this plus this. I'm going to make sure I'm right. 45. Where's my calculator? I had a calculator. Oh, there it is. Plus. Yeah, 45. So I had the first term to the fourth term. 3 plus 6 plus 12 plus 24 is all the way up to 45. Okay. Now, there was a shortcut in order to solve this. Remember, we can find the sum of the series when we say 1 minus r to the n all over 1 minus r all times the first term, right? First term times. So remember, we would say we're going up to 4. So we take the first term, multiply by 1 minus r to the fourth, all over 1 minus r. And I should get this 45. Instead of plugging it in, adding this, I should just be able to plug those in and get the series. Do you guys remember this from last time? Okay. So let's go and see if it works. What's my first term? Is 3. Again, this is Godzilla time. You don't have to write this down. 3 minus. Hey, Ian, can you see this all the way over here?
Yeah, I can.
Okay, thanks. Okay, so I say 1 minus r, my common ratio is 2, which is 2 to the 4th power over 1 minus 2, and I should get 45. 2 to the 4th is 2 times 2 is 4 times 2 is 8 times 2 is 16. So this is 3 times 1 minus 16 over 1 minus 2, or 3 times negative 15 over negative 1, or 3 times 15. Am I in the way? 3 times 15 is 45. So instead of plugging in 1, 2, 3, 4, and then adding them up, I just say 1 minus r to the 4th over 1 minus r, or 3 times 1 minus 2 to the 4th times 2 to the 4th. So anyway, that's what we did last week. If you guys remember, we only did this from the first term all the way up to the 4th term. What we are going to do today is we're going to find the series all the way up to infinity. That's what we're going to do today. Now, I know you're thinking, Sensei, I can't add up to infinity. It's going to take forever, right? Take forever. But that is right. We can't add it to infinity if I keep increasing. However, I can add up to infinity if my common ratio is in between 0 and 1. If it's a fraction, then these numbers start getting smaller and smaller and smaller until it stops adding up. And so without adding them up to infinity, we're going to show you a shortcut. Okay? So that's what we're going to do today. We're going to add all my terms all the way up to infinity. Let's move on. Are there any questions before we move on? Shall we? All right. Miley, you good? Any questions? Carlos? All right. Dennis White, do you have any questions?
No, I'm all right.
Jackson Moreno, are you alive?
Yes.
All right. And Samantha, where are you going?
Somewhere for my mom.
Are you going to a store? What are you doing? Are you going to the movies? What are you doing?
I don't really know.
Ask her. Do you want to know where you're going? Do you want to know where you're going? Is your mom
It doesn't really matter to me.
Huh?
I don't really care where we're going.
Well, don't you want to? I care. I want you to ask. Ask your mom where you're going. I want to know.
All three of you.
A doctor's appointment?
Oh, okay. Well, I hope everyone feels better. Anyway. All right. Let us move on. Dun, 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 dun. Okay. So let's go ahead and look at number 3 on page 387. Okay. Okay, I am turning on my. You guys need graph paper for these first problems here. I'm going to erase this in 10 seconds. Does anyone need it? You didn't have to write down anyway, so. Okay, 5, 4, 3, 2, 1. Okay, so here's what they want us to do on number 3. Okay, we're given a series, a sequence. We're given a sequence, number 3. Let me erase all this. Number 3. Number 3, we're given a sequence of 1/2 plus 1/6 plus 1/18 plus 1/54 plus 1/162. This says consider the infinite geometric series. Notice my series, because I'm adding them up, dot, 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 dot. It means it goes on forever. Okay? And they want us to find the partial sums of n1, 2, 3, and 4, and 5. Find the partial sums. So we're going to add the first term. We're going to add these up. Okay? And then we're going to graph them. So the way to make this easier is let's make these into decimals. Let's make them into decimals. I have here 1/2 is 0.5. 1/6. 1/6 is, let's round it, 0.117. Okay, 1/6 is 0.17. I'm just using my calculator to figure these out. 1/18, 1 divided by 18 is 0.06. 1/54, 1 divided by 54 is 0.02. Notice it's getting smaller. 1/62, 1/162 is equal to 0.006. Okay, we have them listed as decimals. So here's what I'm going to do. Let's add them up. Let's add the series. What is it if I just add the first one? It is 0.5, right? Just add that to itself. Now let's add the first two. The first two is 0.5 plus 0.17 is 0.67. That's going to add the first two. So here's this, 0.67, 0.5. Let's add the first three. 0.67 plus this one, 0.06, which is 0.73. Notice it doesn't get much bigger. Let's add the first four. First term, second term, so 0.73 plus, add the fourth term, 0.02, which is 0.75. Then let's add all five terms, 0.75 plus 0.006, which is 0.756. Notice it's not much, notice it doesn't get much bigger as we go, because I'm multiplying by, what am I multiplying by? I'm multiplying each of these. My common ratio is 1/3. 1/2 times 1/3 is 1/6. 1/6 times 1/3 is 1/18. 1/18 times 1/3, and so forth and so forth. So my common ratio is 1/3. Now they want us to graph this. So you guys doing this on graph paper, right? Make sure you're doing it on graph paper. You guys need graph? Do you have on graph paper? I have graph paper if you need some. Okay, I can't see if that is. It is. Okay, my eyes, they're getting older. Like I can see Bruce Lee and Chuck Norris, but I can't see the lines. Miley, do you need graph paper or you got it? Okay, cool. Hey, Miss Howells, are you done? That's cool. Yeah, we have it, dude. Right. I told them the whole story. I gotta get kids to come. I told them that it's here. my room having Cold Stone ice cream.
Oh, you had an employee come here?
Yeah, there's a Cold Stone. Miss Howell's here. She's eating Cold Stone ice cream right now. She's loving it. She just got the
Birthday cake remix.
birthday cake remix. I got that idea from me. Right? You can talk about that.
Delicious.
So good. Okay. So now we need to graph this. Okay. So now these are the sum of terms. These are going to be my sum of my terms. This sum of the first term, second term, third term, fourth term, up to the fifth term. Now let's add these by twos. 0.2, 0.4, 0.6, 0.8. So they want us to graph these. And then we're going to describe what's happening with the graph. We're going to describe it. Okay, so I take the first term. It's up to 0.5. So I'm all the way up here already in my first term. It's kind of a lot. Then I add the first term and the second term. I get 0.67. So look at how much I go up. Almost up to 7. Then I add the first term, second term, third term to 0.73. I go about here, and I'm right about there. Then I add the fourth term, 0.75, and I'm right here. Then I add the fifth term, and I'm still at 0.75. Notice it's probably going to stay close to 0.75. It will not get past 0.77 or 0.76. So if I was to add them up, what would I say is going on? I would say the sum of the series approaches 0.76. You can see it's going to approach at 0.76 because it flattens right about here, flattens out. And it won't increase much more because of, 1 out of 162 and then whatever, 1 out of, well, what's 162 times 3, right? 500, 1 out of 500. It's a very small piece of the pie. Pie actually sounds really good right now. All right, that's number 3. I'll let you guys do number 5 on your own, but raise your hand if you, I kind of understand what's going on there, Sensei. Raise your hand so I can see. I'm looking, keep your hands up. I'm looking at you, seeing who doesn't understand. Okay. Okay. Sure, you're just saying that because you don't want to feel bad. Like, okay. All right, are there any questions? And you guys can put your hands down if you like. Hand up, hand down, hand up, hand down, hand up, hand down. You know, I think what I'm going to do is dance. Oh, it's not here. All right. So we're good. I'm going to let you guys do 5 on your own. Now let's look at 7. Okay, let's look at 7. No, I'm going to erase this in 10 seconds if anyone needs it. 5, 4, 3, 2, 1. Okay. Okay, I am muting it. Okay, so let's look at number 7. Now, what is 7 asking of us? 7. 7 is asking. 7 is asking, find the sum of the series, first term, all the way to infinity. My first term is 8. My common ratio is 1/5, and then n minus 1 means it's geometric, raised to the n minus 1 power. Hey, Ethan,
Yes.
can you see the red there?
Yes.
Okay, cool. Now, here you guys go. The sum, write this down. This is for your notes. The sum of the infinite series, if I want to add them all up to infinity, there's an equation that we can do. It is going to be, whoops, the first term over 1 minus the common ratio. The first term all over, so write that down. That's how we're going to solve an infinite series. So let's do it. What is my first term for number 7? What is my first term for number 7? Let's go with Jackson. What's my first term? Jackson, I'm marking you absent if you don't answer. 5, Jackson. 4, Jackson, are you there? 3, Jackson, are you there? 2, Jackson disappeared. 4, Jackson. I'm marking Jackson. Where's that guy? Jackson. Jackson, where are you? Okay, if anyone sees Jackson, come up and let me know because I marked him absent. All right, so what is my first term? Let's go with Brett. What's my first term?
8.
8, right? My first term. So to solve this, all you've got to do is write the sum of the infinite series going to be equal to 8 over 1 minus, what is my common ratio? Kevin, what's my common ratio?
1/5.
1/5. So let's solve it, shall we? 8. I'm going to do all the steps to solve it. You can skip the steps if you don't need. But 1 minus 1/5 is 5/5 minus 1/5 equals 8 over, subtract the numerators, 4/5, which is 8 divided by 4/5, which is 8 divided by 4/5, which equals 8 times 5 over 4. 8 times 5 is 40, divided by 4 is 10, or you can reduce, right? 8 times 5, then divide, right? Or this becomes 2. So guess what? If I add all of these up to infinity, it's going to equal 10. That's all you've got to do. Nathaniel, how was that?
It was okay.
All right. Should we do another one, Nathaniel? Or is it so easy you got that? Should I do 9?
We can skip.
Do you think I get a vote for a skip for 9 for Nathaniel? Emma, what about you? Should I do 9 or should I skip it?
You should do 9.
I got a 1-on-1. Let's see. Bryson, break the tie. What do you got, Bryson? Should we do it or should we not do it?
We should do it.
Oh, okay. Let's do 9. I'm going to erase this in 10 seconds. Does anyone need it? Need it? What do you guys think? Would you guys like to do 9? You guys like to do 9?
I just want to watch.
Oh, come watch. We're doing some of the infinite series up to infinity. Yeah. It's not that bad. Okay. Miss Howells is here with her ice cream. You know I made homemade ice cream this weekend?
You really?
I did.
Did you use like rocks? What is it called?
Yes, and you know what? Like rock salt.
Yeah, rock salt.
And you know what? I was like had it in my ice cream maker and it's taken forever. Like had it for like 2 hours. And I checked on it, it was still milk.
Yeah.
Right? And I said, what's going on? And I didn't put enough rock salt in it. So I put tons of rock. I put ton. I was screwed because it's for my daughter. She's being confirmed in
nice.
church. So we're doing a party. And I go, I'll make you homemade ice cream. It didn't work. I was like, oh my gosh. So I went to the store. I bought more ice and I put a ton of rock salt in it, and it froze. So it does make a difference anyway.
You should have made her shake it up herself in like a big Ziploc bag.
I heard about that. That's cool. But this can make I make like a whole gallon of it.
Oh,
I have a
an
machine.
individual serving.
I have a machine.
Very cool. Okay, let's do this.
Oh shoot. Okay, Miss Howell. Sorry guys. You guys want to do this? You want to talk about ice cream? What do you think, Billy? Do you want to talk about ice cream, or you want to do this about the ice cream I made? Billy?
Talk about ice cream.
Ah! I can't. Miss Howell is intimidating me. I feel like I should actually do my job.
Can I see the screen? Or see the board?
We said so. Hey, Linda, can you see this?
Yes.
I read? Huh?
Yes. I can see
Okay,
the
cool. Let me show. Miss Howells wants to see what this looks like.
Oh, it's fisheye.
Yeah, this.
That's the new one.
Yeah, it's not that. It's like a $20 thing. Okay, so I got 11 thirds times my common ratio all over. I'm raised to have it k minus 1 power. Okay, so we're going to plug it in. What is my first term?
Does it show backwards still?
Yeah, but they don't see backwards
They
though,
see
right?
it normal?
Actually, Carlos, can Miss Howell see your screen?
Oh, they see it normal.
I don't know why it does like that.
That would suck if I saw it backwards.
Oh my gosh, I throw the biggest fit.
You'd have to write backwards.
Oh, yeah, that's true. I just do that.
Crazy.
Ethan, what's my first term?
11/3.
There you go, 11/3. So I say 11/3 all over 1 minus. Okay, what's my common ratio? Let's go with Samantha. What's my common ratio?
3/8.
3/8. Okay, you guys go solve that. Solve it up. See what you get. I'm going to ask you what it is. Solve it up. 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 I'm going to call on one of you. Thomas, I like your ceiling. Yeah. Look at people's ceilings. Alonzo. Well, I see Alonzo there, but I don't see. Oh, Nathaniel, are you in a boat or something? That wood ceiling?
No, it's just my roof.
Well, it looks like you're in a boat, like Noah's Ark. I don't know if you've heard of him. He built this ark. I'm wondering if there's a flood coming. You ever heard of the story of Noah's Ark, Carlos? What is the answer? Yeah. What is it? Jackson, are you alive? I marked you absent.
Yes.
Where'd you go?
I got lagged out.
Lagged out. Well, I marked you absent. Stay here so I can fix it. How come your camera doesn't work? You gotta fix it. And you're not in school. I haven't seen you in a long time. I'm sad, Jackson. Jackson, are you there? Can you hear me? Jackson, I'm talking to you.
Yes.
I miss you.
I know. I'll be back Wednesday.
You're not supposed to say, I know, you're supposed to say, I miss you too, Sensei. That's what you're supposed to say.
I miss you too.
Don't you miss me? Come on. Oh, well. All right, Julissa, what'd you get for your answer?
I'm not sure if it's right, but I got 9.7.
I don't know. Let's see what you got. I'm going to write as a fraction. Julissa said 9.7. Okay. Let's see. Abraham, what did you get?
I'm still working on it.
Okay. Let's go with Mara. What'd you get?
I got 88 over 15.
88 over 15. Does that equal 9.7? Let's see. If it's the same, then I think we're doing good. .8. Got two different answers here. Let's take a look. So 11 thirds divided by 1 minus 38, 8 over 8. I'm sorry, 1 minus 3 eighths, 8 over 8 minus 3 eighths equals 11 thirds, all divided by 8 minus 3, 5 eighths, or 11 thirds divided by 5 eighths, or 11 thirds times 8 over 5, which is 88 over 15. That is all you got to do. Dun, 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 dun. Dun, 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 dun. Dun, 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 dun. Bryson, what's that song I'm singing?
The Avengers song.
Yes! Were you guys alive when that was made? Were you too young? Like, when did the first Iron Man movie come out? How old were you guys? I'll look it up. The first Iron Man, was that like 2000, 2009? 2008? How old were you guys back then? Really? Man, that's crazy. I'm going to erase this in 10 seconds. Are there any questions? Five, four, three, two, one. Dun, 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 dun. Dun, 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 dun. Okay, let's do number 11. Number 11 asks us to solve 11, asks us to add these up. 2 plus 6 fourths plus 18 over 16 plus 54 over 64 plus that. Okay. So this means it goes on forever. So we have to figure out our two things. What is our first term and what is our common ratio? So what's my first term? Elise, what's my first term?
2.
2 is my first term. So I'll say my first term is 2. Now, does anyone know how I'm going to solve for the common ratio? You don't find the common ratio, Miley? What's that? Okay. Carlos? No, because it's multiply. We have to find what we're multiplying. If it's geometric.
Oh, divide.
Yeah, divide what by what? You're right.
6 over 4 divided by.
Yes. Okay, very good. Remember that? So to find the common ratio, we divide this divided by that. Or A2 divided by A1, which is 6 fourths divided by 2. Because remember, is 6 fourths divided by 2, or 6 fourths times 1/2, or 6 over 8. Shoot, I should reduce it. Or 3 fourths. After all that, my common ratio is 3 fourths. So now I can find the sum, just put in the 2 and then 1 minus 3 fourths. I'll let you guys solve that on your own. Let's move on, because you guys can just plug those in and solve it on your own. Let's see. You guys solved it on your own. I'm going to get rid of this in 10 seconds. Let me know if you still need it. You guys are looking at me. I'm going to present here. You guys are seeing everything on here? Okay. All right, I'm presenting. 5, 4, 3, 2, 1. Okay. Now let's look at number 17. I don't think it's that difficult. It's just a word problem. 17 Actually, wait, did I skip? You guys did the error analysis on 15. You guys can figure that out. 17. You push your younger cousin on a tire swing one time, and then allow your cousin to swing freely. On the swing, your cousin travels a distance of 14 feet. On each successive swing, your cousin travels 75% of the distance of the previous swing. What is the total distance of your cousin's swing? Assuming this goes on forever, but it gets so small you can't even tell. My first term is 14, right? It's first term, 14. And my common ratio is 0.75. So you put those numbers into this. Okay, see that? Put them into there and you just solve it. That's all you got to do. Put that in your equation, you just solve it. Okay, last thing I'm going to go over. 19. 19 and 21, then we'll be done. Okay, here we go. Are there any questions? Erase this. Number 19. 19. Write this as a fraction. 0.2222 on forever. Okay, let's get you on the screen. Dennis, how am I doing today?
You're doing good.
If you were going to give me a grade for my teaching, what would you give me so far today?
A.
Yes. Yes. Ian, what grade would you give me? For my
An A+.
Yes. Okay. Billy, what would you give me for my citizenship for today? E being excellent, or S satisfactory, or needs improvement for my behavior? What would you give me, Billy?
E.
No.
Excellent.
I'm a bad teacher, man. Bad teacher. I need improvement. You guys don't even want to know what I'm doing. You should have seen what I did to the ice cream truck guy. I'm just joking. Okay, I'll stop. Thank you, though. Thank you, Billy. You're being kind. You're being kind. Okay. So we want to write this as a fraction. We can write this as a series. Look, what's my first term? 0.2. And then what do I add to it? 0.02, right? That's that 2. Then I add this 2. What do I add that? 0.002. Then I add this one. Plus 0.0002 all the way forever. How do I write that as a fraction? Well, what's my first term? Let's make it simple. What's my first term? Kevin, what's my first term?
0.2.
0.2. What is my common ratio? Or how would I figure it out? Ethan, how would I figure out my common ratio here?
I don't know.
Remember how we did the common ratio before? We divide. What do I divide?
The second term over this first term?
Yes, exactly right. Second term divided by the first term, 0.02 divided by 0.2. And then you can divide it in the calculator, or you can move the decimal over, but it's going to be 0.1. Do 0.02 divided by 0.2, you should get 0.1. Okay, so now I have my common ratio of 0.1, and so we can go ahead and figure out what this is as a fraction. What's my first term? 0.2 divided by 1 minus 0.1. 0.2. 1 minus 0.1 is 0.9, or 2 ninths. You divide 2 divided by 9 on your calculator. Look at 2, try it, divided by 9. I don't even know if you can see this. 2 divided by 9, see what it ends up being? Do you see it? Can you see it, Miley? That's what it is. Boom! Right in on time. That clock is broken. What time is it? It is 2:54. What time does class get out? At 3? I'm going to do one more problem. Are there any questions? Let's see, Julissa, did that make sense to you?
Yeah.
All right, Jackson, are you still there?
Yeah.
All right. Abraham, does this make sense?
Mm-hmm.
All right. Okay, one more. Let's do 21. I'll start you on 21, then I'll let you guys go. I'm not going to do 21 for you. I'll let you guys keep going. 21. Write this as a fraction. 21. 21. Write as a fraction. 0.1616161. I think that's it. Is that it? Yeah. It goes on forever. Okay, what's my first term? So, I could write this as 0.16, right? Plus this one. 0.0016 plus this one. 1, 2, 3, 4. 0.123416 and forever, right? So what's my first term? What's my first term? Miley, what's my first term? First term is 0.16. And then let's find the common ratio. Common ratio is 0.0016 over 0.16. Find out what my common ratio is. What is my common ratio? People leaving the class? Don't leave the class. Okay. Okay, tell me what my common ratio is. Get ready to calculate it out. I'm going to call on one of you. I'm calling on you. I am calling on you. I'm looking at you, and I'm calling on you. That is not common. What do you get? That's right. Who should I call? What's the common ratio? Alonzo, what's the common ratio?
I got 0.01.
That's right. 0.01, common ratio, 0.0, and all you got to do is 0.16 over 1 minus 0.01, and then you solve it. I'll let you guys solve that on your own. Are there any questions on today's lesson? Any questions? Make sure you do your check your understanding. Check your understanding. Do it today, right after. All right, let's see. All right, Elise, ask me a question.
When's your birthday?
Oh, shoot. September. Good question. September. Sorry, it already passed, so you don't have to buy me anything. Okay, let's see. Nathaniel, ask me a question.
Are there ice cream on Wednesday? Do you still have ice cream on Wednesday?
Ooh, that's a good question. If it's available, I'll have ice cream if it's available. It costs me a lot of money to have this guy over here. There's like 30 kids, and then all the teachers. It costs me like $1,500. You know what I mean? This guy, look at him. Look at him over there. You see what he's doing? Can you see that? You see that? Like how he's doing that? It's crazy. Oh, he's supposed to flip. Hopefully you saw that. I tried to show you where the ice cream guy is. Okay. All right, if there's no questions, I'll let you guys go. I'll see you tomorrow. See you guys tomorrow. I love you guys. Bye, Thomas. Bye, Ian. Bye, Alonzo. I love you. Bye, Linda. Bye, Julissa. Bye, Bryson. Bye, Nathaniel. Oh, pizza. What does that mean, Nathaniel? I don't even know what that means. Bye, Billy. Bye, Angel. Huh? In what language?
Deodorant.
What?
Use.
Tagalog? Oh.
You know what that is?
Who's saying that? There's Jackson. Why did you finally turn your camera on?
Sensei.
What's
to say
that?
hi to Brett.
I didn't get the I sent you an email last